sorry for that break. Here comes part 2, okay? We just found the value of x. Now I need to find the measure of RP. The only way to do that is come up with the value of y. Now I know RP is going to be the same as this piece, but I don't know what that is. So it's going to be tough to find the value of y unless I look around and I see that y exists somewhere else. Well, 3y minus 2 is side LK. I know LK has got to be the same as RQ, which is here. So I go 3y minus 2 equals 22. If I add 2 to both sides, I got 3y equals 24 divided by 3. Y is going to be 8. So if I want to find, I got to plug 8 in there. So 2 times 8 is 16 minus 1, 15. All right, the dreaded proofs. All right, try and remember the structure here. This given is going to be early on. I need to make sure all of this given ends up inside this proof. So part of the given I can see is here. I can see the rest of that information came in down here. I know my proof's supposed to end at saying those triangles are congruent. So I want to read this, see if I can understand. It says O is the midpoint of segment MQ. MQ is here, O is in the middle. Okay, so step 2, they said, well, MO has got to be congruent to QO. Well, that makes total sense. We just said O was the midpoint. So I know this has got to be true because I know what a midpoint means. So I'm going to put definition of a midpoint. If we bring up the term in a courtroom, then we can use it. So they're trying this game again. O is the midpoint of NP. So they're going to say NO is the same as OP. That's the same move. Again, definition of a midpoint. Now this next one, angle, MON. The angle MON, they're saying that this has got to be congruent to QOP right here. I totally agree. This is one of the things we're supposed to be looking for. Those angles have to be congruent. They're vertical angles. If you get the word vertical in there, I'm great, but it's really called the vertical angle theorem. But if you knew that word vertical in there, we'd be good. Now, if I want to prove the triangles are congruent, one of my shortcuts has got to be going on. I got 2 sides and an angle in between. That's just an SAS move. Don't be afraid of these proofs. You can do these. Now, if we get here, they're saying classify each triangle by its angle measures. X, Y, Z, that's this triangle here. I know 2 of the angles. I can find the third one. Those add up to 95. So if I take 180 minus 95, I get 85 degrees. Now I know all 3 angles. They're all less than 90 degrees. That's my acute triangle. Let's look at the next one, XYW. XYW, look at the whole thing. I know one of the angles is 60 degrees. This angle is 35 plus 25, which is also 60, which means I know this angle up here has also got to be 60 degrees because, again, they got to add up to 180. If I got 180, if I get rid of 60, get rid of another 60, I'm left with 60. If they're all equal, that's called equiangular. Now this last triangle here, I have a linear pair here, which means they have to add up to 180 degrees. 180, get rid of 85. I know the other angles, 95. That's bigger than 90 degrees. That's my obtuse triangle. Come on, know these words. Study them. The only triangle that didn't exist in there was a right triangle, okay? Now we're classifying by the lengths, DEF, DEF, the whole thing. I know this side is 10. Well, we got congruence mark, so the bottom's 10. And this has got to be 2. Oh, that's got a mark for, that's 8. So if I put 2 and 8 together, that means this last side is 10. If all the sides are 10, I'm going to call that equilateral. These are all in your notes. DEG, that's this tiny little one. One of the sides is 2, one's 8, one's 10. They're all different. That's called scalene. Scalene, spell right. Scalene. EFG. Well, 2 of the sides measure 8 and 8, and the bottom's 10. If 2 of them are the same, that's isosceles. We're doing good. 3 pages down, 1 left. We've seen this one before. All right. Here, they've told me 2 sides are the same. I don't need to use this. I'm going to say 8x minus 5 equals negative 3x plus 17. I'm going to add 3x over here. To get rid of that, I got 11x minus 5 equals 17. And if I add 5 over here, I got 11x equals 22. Divide both sides by 11. X happens to be 2. They wanted me to find the value of x and all the side lengths. So I'm going to take 2, and I'm going to go plug it in. 5 times 2 is 10 minus 9. That means this side measures 1. I'll just choose. I know these are the same, so I'm going to plug 2 into here. 8 times 2 is 16 minus 5. 16 minus 5 is 11. So my other 2 sides are 11. Okay. They want me to find the measure of angle B. Well, if this is isosceles, then the 2 base angles have to be the same. So if that's x, I'm going to call this x. And I'm going to make an equation because I know all the angles have to add up to 180 degrees. So I've got a good equation here that I can solve. I got 5x's. If I divide both sides by 5, 5 into 180 is 36. X is 36, but they want to find the measure of angle B. Oh, angle B is also x. So this is also angle B. Last problem. Find the measure of angle H. We got to find HEF, which means I got to find that angle and this one and put it together because HEF is the big angle up there. So let's start doing this. I've got an isosceles triangles, which means that angle's got to be the same as this one. 180 minus 110 is 70 degrees. That means these 2 angles have to total up to 70. Since they're the same, cut them in half. This angle's got to be 35 degrees. This angle's going to be 35 degrees. Again, I got a linear pair. We've been using this all year. If that's 110 degrees, then this has to be 70 degrees. It's isosceles, so the 2 angles here, down here, have to be the same. 70 and 70 makes 140. If I take 140 from 180, I know I'm down to 40 degrees for this angle up at the top. Now, my answer is not 40, and it's not 35. I got to put them together. My answer is 40 plus 35 is 75. There's my answer. All right, please review this. Know these problems. Be ready for the test. The test should be about showing off, not being confused. Best of luck. Have a great day.